Good morning, you guys, or afternoon. So we've been talking about maximum and minimums, and what that means is where the function reaches the highest point or the lowest point. So we've talked a lot about that, but we haven't really discussed how they get there. So where a function is increasing and decreasing is how you can determine, we're going to learn how to determine that. So we know where max and mins are, just not where it's necessarily getting to that point or coming away from. And just remember that you can pause this anytime to catch up on the notes. So a function f is increasing on an interval if for any two numbers x1 and x2. So that's just your interval. That's where it's between in our brackets. X1 is less than x2, which implies that f of x1 is less than f of x2. And a function f is decreasing on an interval if for any two numbers x1 and x2. So between any 2 points is what it's saying, where x1 is less than x2, f of x1 is greater than f of x2. So again, this is to see where it's going up and not then where it goes back down again. So we're not looking at the highest and the lowest point like before, but we're looking at where it increases and decreases. So the test for increasing and decreasing functions. Let f be a function that is continuous on the closed interval ab and differentiable on the open interval ab. If the derivative of f at x is greater than 0, then it is increasing. So when we found max and min, it was opposite. If the derivative, it was the second derivative first of all, and if the second derivative was greater than 0, then that was a minimum. If it was less than 0, then that was a maximum. So here we're talking about the first derivative, and it's saying if the first derivative is bigger than 0, then then it is increasing. If the first derivative is less than 0, then that means f is decreasing. So you have to look at whether it is greater than 0 or less than 0. If it equals 0, then it's constant at that point. And what does it mean to be constant? You have to think about that. So a constant function is just a number, meaning it's a horizontal line, meaning it has a slope of 0. Okay, so it's not going up or down at all. It's just a horizontal line straight across. It crosses the y-axis somewhere. So you can see on this graph here, it's decreasing when the derivative is less than 0. At the bottom, that could be a max or a min, where the derivative equals 0. It would be a minimum in this case, actually. But it's not increasing or decreasing at that point. And then where it's going up, and then it stops. So go ahead and make sure you copy that down. Again, if you need to pause this at any time, do so you can get the information down. So you're using the first derivative to determine max and min, or I'm sorry, increasing and decreasing. So how do we find the intervals for which a function is increasing or decreasing? So we're assuming f is continuous on the interval, first of all, the whole interval, a to b. So step 1, you need to locate the critical numbers. So remember, to get critical numbers, you find the derivative and set it equal to 0. So take the first derivative, set it equal to 0, and solve for your variables. And use those numbers to determine test intervals. So we're going to need our test intervals again, like we did when we were finding max and min. However, it's a little bit different than increasing and decreasing. If you don't know, so right here, if we don't know our interval, if it doesn't tell you anything, you assume you're going from negative infinity to infinity. So you're going the whole way. Step 2, determine the sign of the first derivative at least one test value in the interval. So you're going to be testing from negative infinity to 0 and 0 to infinity maybe. So you would determine one of the you would plug in a number to the first derivative and see if it's positive or negative in your intervals. Remember, you're testing a lot of intervals because we're seeing where it's increasing and decreasing. We're not just looking at the lowest and highest point. Step 3, use your test for increasing and decreasing to determine whether f is increasing or decreasing on each interval. And that test was from the previous page. I'm going to go back really quickly. right here. So if if the derivative is greater than 0, then that means it's increasing. If your derivative is less than 0, then that means it's decreasing. And if your derivative at that point is equal to 0, then it's constant. It's not doing either. So you would look and see what you get, positive, negative, or equal to 0 for each of those points. So again, our guidelines. Okay, so we're going to try an example. So find the open intervals on which, hold on. We need our function, huh? Find the open intervals, there we go. Okay, sorry about that. Find the open intervals on which the function f of x equals x cubed minus 3 over 2x squared is increasing or decreasing. So note, like I said, there is no interval that they give you. So you're assuming you're going from negative infinity to infinity. That's our whole interval. That's on A, B, and then we're gonna, if we recall from the previous page, step 1 is to find critical numbers. So how do we find your critical numbers? You take the derivative and set it equal to 0. So the derivative of this function is 3x squared minus 3x, because we bring the 2 down and the 2's will cancel when you bring it down. You got to have essentially 6 over 2, which goes to 3x. I am just making this, I set it equal to 0, but I also factored out a 3x from both sides. So if I redistributed this, 3x times x is 3x squared, 3x times 1 is 3x. So it's the same as this, I just factored it out. So what would x have to be in order for this function to equal 0? You can see that x is either 1 or x is 0. Step 2, you're going to need your table. So remember I said your interval, these are our critical numbers. 1 and 0 are our critical numbers. And this is our overall interval. So we want to know from negative infinity to infinity where your function is increasing, so going up, and where it's decreasing, going down. So we're going to test between negative infinity and 0. That's our first test interval. Because 0 is a critical number, then this is our lowest value. Then we have to test between 0 and 1, and 1 and infinity. So we pick numbers. You can pick any value between all of those and test it. Remember, we're looking at the sign of the derivative at that point. So I would pick easy numbers to work with. So between negative infinity and 0, remember it's not less than or equal to, it's just less than. I'm going to choose negative 1. I'm going to let x equal negative 1. I'm going to plug negative 1 into my derivative. So plug it in, 3 times negative 1, or here, negative 1 squared is just 1, 3 times 1 is 3, minus 3 times negative 1, we get f of negative 1 equals 6, because minus and negative, you add them. So 6 is bigger than 0, which if your derivative is greater than 0, that means it is increasing. You're going to do the same thing for here and here. You're going to pick test values and then plug it into the first derivative. So I picked 1/2. Remember, you want to pick the easiest numbers you can to work with. And remember, you're plugging into the derivative, not into the original, because we're just seeing where it's increasing or decreasing. So f of 1/2, f prime of 1/2 is negative 3/4, which is less than 0. Which tells me it is decreasing at that between 0 and 1. And I picked 2. 2 squared is 4. 4 times 3 is 12. And then 12 minus 6 is 6. So you can't see it there, but f prime of 2 is greater than 0, meaning your function is increasing. So you're still just going through your steps that we have learned. So if I went back, I know these didn't come up in the right order, but I'm going to go back real quick. There we go. So we followed these guidelines. We found the critical numbers. We plugged in, so determine the sign of the derivative of f at x at one test value in each interval. Those intervals were the negative infinity to 0. 0 to 1, and 1 to infinity. So we picked a number in that. You could have chosen anything. You could have chosen negative 5,000, and you would have still got at that negative 5,000, the derivative is bigger than 0, meaning it's increasing. Okay, you could have chosen 0.2222222 for 0 to 1, and it still would be decreasing. No matter what you put in between 0 and 1, you would have gotten a negative number. If you didn't, you made an error somewhere. And then the last part was, or then 1 to infinity. So anything bigger than 1 would work. So then you test it and determine if it's increasing or decreasing. And then you can tell, so this did not come in the right order, I'm sorry about that. There we go. So we can tell, there we go, if it where it's increasing and decreasing. So this is like the worksheet I gave you. It says problems, especially the second part of it, you have to determine increasing and decreasing. I hope this helps. Please email me if you have any questions about the homework, anything, and I will do my best to answer it. Make sure you answer all parts of the questions on the homework. And this is all, yeah. So have a great Thanksgiving break. Let's see.